Okay, so in this video we're going to be looking at the sine rule. So the sine rule is one rule that we can use when working with non-right-angled triangles, particularly when we know about the angles in the triangle, or one or two of the angles in the triangle. The sine rule would allow us, it gives us a relationship between the side lengths and the angles in a non-right-angled triangle. Now, it can't be used all the time. In the next video, we'll look at another rule called the cosine rule. So it relies on a particular combination of information to be able to use it, but it is one of two key rules that we'll use in non-right-angled triangles to relate the side lengths and the angles. So obviously, SOHCAHTOA relates the side lengths and the angles in right-angled triangles, and I wouldn't overcomplicate right-angled triangles. The sine rule will work in a right-angled triangle, but it's unnecessarily complicated. So stick with SOHCAHTOA if you have a right-angled triangle. Non-right-angled triangle, you're going to need the sine rule or the cosine rule, which we'll look at in the next video. Okay, so let's establish the sine rule first, and then we'll look at how to use it. So we've got our non-right-angled triangle with our naming conventions we introduced in the last video. So capital A referring to the point or the angle, and lowercase a referring to the opposite side length. Okay, so capital B, this would be angle B here, and this would be side length, lowercase b over here, etc., etc., and the same pairing with C and C. Okay, so from the previous video we learnt about how to find the area of a triangle, and we found that it was half times we multiply two side lengths together, and then we get multiplied by sine of the included angle. So half times b times c, so if we're using side lengths b and c, we would have to use the included angle a inside the sine. Or if we wanted to work it out this way, we could do half times a times c times sine of the included angle, so b. Okay. Or if we knew about a and b, we could do half times a times b times sine of the included angle, so sine of c. So all three of those formulas calculate the area of this triangle. We would just use whichever one is relevant depending on the information we're given in the triangle. So what we know, therefore, is that this has to be equal to this, which has to also be equal to this. So these three things are equal to each other. So we've got that here. Okay, so then we can multiply everything in this equation by 2 to get rid of the halves. So if we double everything, it's still therefore true that BC sine A times sine A is equal to AC times sine B, which is equal to AB times sine of C. So that's this. Okay, then what we want to do is we want to divide by ABC. So if we divide every side of this triangle by ABC, every side of this equation, sorry, by ABC, in the left-hand side of the equation, the B's will cancel and the C's will cancel, and we just get left with sine A over A, which is what we've got here. In the middle part of the equality, we get the A's will cancel and the C's will cancel, and we get left with sine of B over B, which is what we've got here. And on the right-hand side of this equation, the A's will cancel, and we get left with sine of C over C, which is what we have here. Okay, and so this is our sine rule. Sine of A, so sine of an angle A, divided by its opposite side length, A, is the same as sine of a different angle B, divided by its opposite side length B, which is the same as sine of another angle C, divided by its opposite side length C. And we can also take the reciprocal of this rule, so we can flip all of these fractions and it's still the same rule. So it's the same as saying A divided by side length A divided by sine of angle A is equal to side length B divided by sine of angle B, which is equal to side length C divided by sine of angle C. Now we wouldn't use all three, we wouldn't use set up an equation with two equal signs in it. Okay, so depending on the information, we might be using that equation, we might be using that equation, we might be using that they are equal, okay, we might be using this, alright, so we use the variation of it that suits the information that we have. Okay, so as I said at the beginning, the sine rule provides a relationship between side lengths and angles of non-right-angled triangles, and we can either set it up this way with sine of the angles on the numerator. I would do that if the angle is the unknown thing I'm solving for, or we can set it up with the side lengths on the numerator, and I would use the latter version if it's a side length I'm trying to find. So I always like to set things up with the unknown thing at the top left, and then, you know, everything else can follow from there. So if the unknown thing is angle B, then I'm going to put sine of B up here, so that has to be B down here. And then if I know about C and C, well, that would be sine of C over there. Or if I knew about angle A and side length A, that would be sine of A over there. Okay, so whatever it is. Start with what you're trying to find at the top left and then work out everything else around it. Okay, let's get on to using it. So as usual, I don't want you to get bogged down in what's A and what's B and what's C. The whole idea is sine of an angle divided by its opposite side length, okay, is equal to sine of another angle divided by its opposite side length, which is sine of another angle divided by its opposite side length. So don't get bogged down in the A, B and C. Okay, find the value of x correct to 2 decimal places. Okay, so one of the key things with the sine rule is obviously we're going to need 3 known bits of information to be able to find a fourth. And we're going to need, in particular, if we want to use the sine rule, at least one combination of information has to be an angle with its opposite side, okay? So this is what is going to allow us to use the sine rule here, because we know that particular combination. All right, so I've got this angle here, but I don't know its opposite side length, so it's a bit useless to me. I'm trying to find this side length, which means this is the angle that's going to be important. Okay, so the first thing I'm actually going to need to do is work out that angle there, because that's what I'm going to be interested in. I'm trying to find x, I'm going to need that combination of information, and I need to have one combination of information where I know both the angle and the opposite side length, which is the yellow stripe. So we're going to need to work out that angle there, so let's just call that theta for a minute. Okay, so we know that theta is going to be 180, well actually let's not call it theta, oh yeah, sorry, the triangle's not labelled, so theta will be 180 minus 58 and minus 12, minus 79. So 180 minus 79 is 101. So we're just subtracting 57, so it should be 43. But you've got a CAS. Get your CAS to do it. 180 minus 58 minus 79, 43. Okay, so now we want to set up our sine rule. As I said, I always start with my unknown thing on the top left. So our sine rule is going to be something divided by something else equals something divided by something else. I always put the unknown thing on the top left. It makes the equation solving easier, although it doesn't really matter in further maths because you always have a CAS, so you're going to solve it with your CAS anyway. But habits die hard. So x is my unknown thing. I want that to go on the top left, which means I'm going to have lengths on the top and sine of angles on the bottom. Okay, so it's going to be x divided by sine of the angle opposite it, and in this case that's 43. Is going to be equal to another side length, so we're going to use the yellow combination of information, 12 divided by sine of the angle opposite it, sine of 58 degrees. Okay, so by setting it up with the x on the numerator, it's much easier to solve by hand, and in fact I would still recommend for most of you it's a relatively easy thing to get x on its own. X is being divided by sine of 43, so to get x on its own I'm going to need to multiply by sine of 43. So 12 over sine 58 and then multiplying by sine of 43. And that's actually going to be much easier in terms of what I type into my CAS because I've done the solving myself. So solving means to get x on its own. Okay, so I've solved. Okay, so when you're using your CAS, you don't need to solve anything here if you've got x on its own by yourself. You just need to get your CAS to tell you what that is as a number to 2 decimal places. Okay, so no need to solve, control divide, 12 divided by sine of 58, check making sure you're in degree mode, which I am, and then multiplying that by sine of 43. Control enter to get it as a decimal. To 2 decimal places, x is 9.65 and x is a length and it's in centimetres. Okay. If you hadn't done this middle step where you did the solving yourself, then you would need to get your CAS to solve. Okay, so then you would need to do menu 3.1, control divide, x divided by sine of 58 equals, control divide, 12 divide, it's sine of 43 on that side, sine of 43 equals 12 divided by sine of 58, comma x, control enter. Okay. So in the first example where I did the solving myself, i.e. I got x on its own myself, then all I need my CAS to do is it doesn't need to solve anything. It just needs to evaluate. It just needs to work out what 12 over sine 58 times sine 43 is. So you don't need to use menu 3.1, you don't need comma x, etc., etc. You just literally type this expression into your CAS. Whereas if you want to go straight from here to the answer, your CAS is going to need to do the solving for you, and so you will need to have solve, put in the equation, comma x in your CAS. Okay, so whilst this middle line isn't necessary, it's a slightly easier calculation with your CAS, and it's not that hard. So if you're capable of doing that, I would encourage you to get the x on its own yourself. Alright, question 2. In triangle ABC, angle A is 52, side length A is 10 centimetres, side length B is 7 centimetres. Find angle B correct to 1 decimal place. Okay, we haven't got a triangle. First thing I would do is draw out the triangle. It doesn't need to be to scale at all. Just draw a triangle. I'm going to call this A, which makes that 52 degrees, which makes this 10 centimetres. B is 7 centimetres. Now, given that that's shorter than 10, I'm going to label that as this one. So that's 7 over there, which means this is going to be B here, and so therefore that's the angle I'm trying to find. So the important information, I have a combination of information where I have the angle and the opposite side length. So that's going to allow me to use the sine rule. I'm trying to find this angle, and I know its opposite side length, so I'm going to be able to use the sine rule. Okay, so this time it's the angle that I don't know, so I'm going to put sine of B on the numerator. Divided by its opposite side length is 7, and therefore I need to use the ratio in the same way on the right hand side, so I must use sine of 52 on the numerator, divided by 10. Okay, there's a couple of things to look at here. We can do this rearranging by ourselves, but this is a bit more complicated. Finding side lengths is easier, finding angles is a bit harder. Now it is possible, because we could multiply by 7, so we could do this. I don't want you to don't write this down for a minute. Actually you can, but I'm going to go back and have a look at how I would actually probably do it. So sine of 52 divided by 10 and multiply that by 7, okay? So we could get our CAS to work that out, what that equals. So sine of 52 divided by 10 and multiplied by 7. Oops, sorry, control enter. Okay, so that is 0.5516. I know I want my final answer to 1 decimal place, but that's not my final answer, so I'm just going to keep that to a bit more accuracy. And then we know to solve for B, so this doesn't equal B, this equals sine of B. And so we know that B would be inverse sine of 0.5516. And so that is, I always do that, inverse sine of this answer here. 33.1 decimal place, 0.5 degrees. Okay, I actually wouldn't advocate doing the solving yourself when it's an angle that's unknown. And I know I just, in the previous example, advocated it up here. It's not necessary, but it's perfectly possible here and fine. But when it's the angle that's unknown, and we'll see this in a minute when we talk about the ambiguous case for the sine rule, if you do the rearranging yourself, you might miss that there is a second solution. So I would encourage you to always use your CAS to solve when it's an angle that's unknown, because sometimes with the sine rule, we'll talk about this in a minute, there could be 2 correct answers. And if you do the rearranging yourself, you won't recognise the second correct answer. There's a way you can do it, but I would just use my CAS to solve right from the outset. So rather than doing the rearranging myself, I'm just going to solve this equation. So I'm going to put that in my CAS. Menu 3.1. Solving an equation, control divide. I'm going to need sine of B. Doesn't matter whether you use uppercase or lowercase, it doesn't distinguish your CAS. Sine of B over 7 is equal to sine of 52 over 10. And we're going to need to solve that for B. Now, our CAS, when I press enter here, or even when we press control enter here, is going to give us something unexpected. Now, it's not unexpected, and if you do maths methods, you'll have an idea of what's going on there. But it's actually because when it's the angle that's unknown, there is an infinite number of solutions. Now, they're not all practical when we're talking about a triangle. So what we want to think about is, well, what do we know about angle B? Okay, so we know there's already 52 degrees here. We know all the angles in a triangle add up to 180. So 180 minus 52 is 128 degrees. So we know B has to be somewhere between 0 and 128 degrees. And our CAS needs to be told that in order for it to give us a particular solution. And the way we do that, I'm just going to scroll up here and press enter to copy that calculation again. Outside of the solve function, so I've closed off the bracket, I've got my solve, open bracket, equation, comma, thing I want to solve for, close the bracket, and then outside of that, we're going to use given that, so I've pressed control equals. I need this given that symbol, and then I need to tell it that the angle is somewhere between 0 and 128. So 0 is less than B, which is less than 128. So that says that B has to be between 0 and 128. And now when I press Control Enter, it will give me the only solutions that fit that particular criteria. Given that we're talking about a triangle, that's the only one I'm after, and that's at 33.5, which we found by rearranging ourselves. Now, as I said, if you're trying to find the angle, I would advocate that you always use solve. It is cumbersome because you do have to put this restriction, so it is tedious to type it into your CAS, but it will ensure that you don't accidentally miss when there's a second solution. Okay, so I would use CAS to solve always. Okay. All right. So the box here just talks about solving equations with trig ratios using CAS. So when you solve for a length, that's fine. There's nothing complicated. You just solve for x. However, when it's the angle that's unknown, you will need to put, you'll get this, what we call a general solution, which is not helpful. So you need to put this restriction, and it goes after the solve function. The most common error students make is they try to put it inside this bracket. So close the bracket, given that, and then the restriction. And then by doing that, you'll get the solution you need. Okay, let's have a go at another one. So consider a triangle ABC in which B is 39, B is 20, or angle B is 39, side length B is 28, side length A is 41. Find A correct to one decimal place. Okay, so let's have angle B, sorry. Oops. B is 39, the side length opposite B is 28 centimetres. Side length A is 41 centimetres, let's make that this one, so that makes that corner A. Find angle A. Okay, so again, we've got that important combination for the sine rule where we know an angle and its opposite side length, and then we are going to try and find the angle opposite the side length that we have been given. Okay, so you want to set it up. So again, angle unknown, I always put the unknown thing on the top left, so sine of A divided by the side length opposite it will be equal to, sine of the angle that we know, 39 degrees, divided by the side length opposite it. Again, we could do the rearranging ourselves, but I'm not going to do it because I'm trying to find an angle, and in order to ensure that I don't miss any solutions, I'm going to always use my CAS. So menu 3.1, control divide, sine of A over 41. You don't have to use A in your CAS, you can just use X, but make sure you use letters consistent with the question in what you write on the paper, and that's why I would encourage you to use the same letter in your CAS. Otherwise, if you use X in the CAS, you'll have a tendency to write X equals something here, and that's not what you're being asked to find. Okay, so sine of A over 41 equals, control divide, sine of 39 over 28. We're going to need to solve that for A. Because we're solving for an angle, we will need a restriction. So we need to think about what we know about A. So we've already got 39 degrees in the triangle. 180 minus 39 is 141. So there's 141 degrees left to be shared between these other two unknown angles. So therefore I know that A has to be somewhere between 0 and 141. So 0 is less than A, which is less than 141. Oops. Control Enter to get my answer as a decimal. What have I done there? Solve that equation for A. Sorry, I've accidentally put times. I didn't put the given that. So control equals to get the given that symbol. Sorry, I'm not sure what happened there. Given that, A is between 0 and 141. Control Enter to get it as a decimal. Alright, and you see this time we've been given two solutions, and they're both between 0 and 141, and so actually they're both possible. So what we see here is A could be 67, what do you want, one decimal place, 67.1 degrees, or it could also be 112.9 degrees. Okay, and if we hadn't used the CAS to solve, if we'd rearranged it ourselves and instead worked out, well, what is 41 times sine of 39 over 28, and then done inverse sine of that, we would only have got one of those solutions, but they're both correct and they both need to be listed if there are two correct solutions. Okay, so it's really important, that's why I would always advocate use the CAS to solve, rather than try and do the rearranging yourself. Now the angles, when you get two solutions, the two angles do add up to 180. Okay, so if you want to insist on doing the solving yourself, I would always then encourage you to do 180 minus the answer that you get, and if that's also going to not going to make the triangle exceed 180 degrees in total, then that's a valid solution. What we would have found up here in this this previous example, if we have a look at, I've still got that number up there, so let me just do, if we do 180 minus that 33.5 answer that we found, there it is, that's 146, but that's not, that would have made the total angles in the triangle exceed 180, so therefore that's why this is the only possible solution. Whereas when I subtract 67.1 from 180, I get another angle that also works within the triangle. Let's have a look at the geometry of what's actually happening here. So actually it's a different example down there. So let me try and show you the geometry of what's going on here. So let me just redraw this triangle. Well, actually we can leave it as it is. So what the thing is, the ambiguity here is we're trying to find this angle in here. Let me just get rid of that highlighting out of the way. We're trying to find that angle in there. And what we can do, the length of that line that I've just highlighted in purple there, that's fixed. But what I could do, if you imagine fixing it to this point here, okay, and then you imagine it like a pendulum where it can swing, okay, it can swing out and around, okay, then we can still have another length over here that's also 28 centimeters. Sorry, I haven't drawn that very well. Let me just extend, yeah, so if we were to extend out our triangle, extend out this length, because this length we don't know, it's not fixed, and we imagine taking that purple length and swinging it around like it's on a pendulum, so that's, try and draw that straight, so that's 28 centimeters there as well, then we've got a triangle with an acute angle. So what we have here is, that yellow triangle still has all the same information that was given to me in the question. 39-degree angle at B, 28 centimeter angle opposite that, and a 41 centimeter angle here. And that we can see from that diagram we get an acute angle. So this would be the 67.1 degree solution, the triangle that's highlighted in yellow. But the alternative is the one that I had originally drawn, this green triangle here, where it still meets all the same information. The 39-degree angle at B, the 28 centimeter side length opposite it, a 41 centimeter side length, and when we work out the angle opposite the 41 centimeters, we can see that it has to be obtuse, and so this would be the 112.9 degrees. So we've actually been given a set of information that's ambiguous. It's not enough information to define one unique triangle. Okay, so actually what we find when we solve it is there's two possible values for A because there's two possible triangles that fit the information given in this question. So here's another example here. So if we had triangle ABC where angle B is 35 degrees, side length B is 6 and side length A is 10. So if I draw it this way around and I say, well, that's side length A there, that's side length B there, and that's angle B there. Okay, so obviously this angle is fixed, so I can't change the direction of these two side lengths. Okay, I can extend this one out. This length of this one's also fixed. Okay, so that length is fixed. The size of that angle is fixed, so this has to keep going out, but it can go out for as long as I want. Okay, and this length is fixed. Let me get a different color. This length here is fixed. This orange length has to be 6. Okay, but this angle's not fixed. This angle's not fixed. And this side length down the bottom here is not fixed. So again, if I imagine affixing that point at C and treating this orange length as a pendulum and swinging it around, I mean obviously it can swing around in a complete circle. It's not a good diagram, let me try again. It could swing around in a complete circle with that same radius, but if I imagine swinging it around here so that it still has length 6 centimeters, now I see that it's possible that there is an an obtuse angle as well as the acute angle that I'm seeing in here. So when I set up the sine rule to solve this, sine of A divided by 10 is equal to sine of 35 divided by 6, and I get my CAS to solve it with a correct restriction. If I've already got 35 degrees in the triangle, there's only 145 degrees left, so A has to be somewhere between 0 and 145. There are actually two values between 0 and 145 that fit. And so one is acute, this would be the 72.9 degree angle, and the one is obtuse, this would be the 107.1 degree angle. Okay, and so it's an ambiguous case where there are two possible and two correct solutions. And if there are two correct solutions, you need to give two correct solutions. Okay, it wouldn't be correct to just give one of them. So that's where using solve to find A rather than doing the rearranging yourself is going to ensure that if it's an ambiguous case, it's covered. Okay, and so there's the diagram there for you. So sine rule, if you're finding a length, it's a bit easier. Length over sine of an angle equals length over sine of an angle. Use your CAS to solve if you want, or rearrange by hand if you want. If you're finding an angle, sine of that angle over the length opposite it equals sine of another angle over its opposite length. Use your CAS to solve it to ensure that you're not tripped up by this ambiguous case situation. Okay, so exercise 18B is the work for today.